So for our third task, we're going to look at the domain of a function, or what x values it could have, the vertex of a function, and the zeros. So here are four sets of quadratic functions. We're going to describe a domain that's appropriate. So we're going to look at the upper limits, lower limits for the inputs. We're going to estimate the vertex of the graph and describe what it means, and identify or estimate the zeros. So if we have the area of a rectangle, so this function represents the area of a rectangle with a perimeter of 25 meters and a side length of x. So first, this is where the area would be positive. And if we're talking about a rectangle, it can't have a negative area. So if I'm looking at the domain, again, that's the x values. And the x values here can go from 0. And then if we're looking at a scale to put on here, the perimeter is 25. So we could have all the way up to 25. So our domain here would be x is between 0 and 25. And it couldn't be 0 or 25. It has to be a little bit bigger than them. So the domain would be x is between 0 and 25. Now, the vertex is going to be the highest point. So here is our vertex. And we have to list the vertex as a point. So this looks to be about 15 and 40. And then the zeros seem to be at x equals 0, or you could list that as a point. X-intercepts also. And another 0 happens to be here if x seems to be about 25. But we have to look at that scale here because we don't have that. I'm noticing that x would be 0 here if x equals 12.5. So this seems to be about 12.5. So what we can do here is just graph this and find those directly. So we can put this into our calculator and just put x and then times. So I can go x times and then put in a fraction by pressing alpha x. Then here, this would be 25 minus 2x in the numerator and 2 in the denominator. So let me change my window here. We can go from 0 to 25, and then here from 0 to, let's say, 40. And then what I can do is calculate these points. So the vertex is a maximum. So if I go second, calculate, and go to the maximum, the left bound means I need to go to the left of the maximum point, hit enter. The right bound means I need to go to the right of the maximum point and hit enter. And it looks to be at about 6.25 and 39.06. So this scale is not the same for x and y. So the scale was off. So 6.25 for x and about 39.06 for y. So our domain for x then, this is going to be about 12. So what I can do there to verify that, you can go second, calculate, and find a 0. So we need to go to the left of this 0, hit enter, and then go to the right of the 0, hit enter, and the other 0 is at 12.5. So this domain, we need to adjust it. This isn't 25, this should be 12.5. And then lastly, our zeros are x equals 0 and x equals 12.5. So that is not approximate. Just cross it out, and it would be x equals 12.5. So we're going to continue with this and practice our function some more and putting those into a calculator. So here we have the number of squares as a function of the step number, n squared plus 4. So if I look at the domain, well, we could only have squares from a step number that is positive. It doesn't really make sense to have a negative step number. So the domain, we can just say x is greater than 0. You could have a step number, any number bigger than 0. And then our vertex seems to be about here. And that would be 0 for x. But if I'm looking at the y-intercept is going to be 4 for y. So my vertex is going to be 0, 4. And then if we look for zeros, that's when the graph touches the x-axis, it would be none. So if I just want to verify that y-intercept, what we can do is put that function in. So I put in x squared plus 4. So x and then squared and then plus 4. I graph it. And you notice we only have the positive values because my domain is set to be bigger than 0. And what I can do is calculate. And what we want here is a minimum, because we're going to go for the bottom of the parabola. So what we can do is make our x number go to the left of that minimum. So I'm making it go off the screen here, and it adjusts. And I go over here. The right bound of the minimum is there. And we're at, 0 for x and 4 for y. And then it doesn't touch the x-axis, so there's none. So now the distance in feet, an object has fallen t seconds after it's dropped. Again, you really can't go back in time. So our domain here would be x values are greater than 0. So really this entire part of the graph does not fit our math model. Our vertex here, I can look at the function and say this is 16t squared plus 0. The vertex is going to be at 0, 0 for y. And then this touches the x-axis at x equals 0. So that would be listed as a 0. So to show that, we can put this in, y equals, clear that out, put 16x squared, graph it. And then we wanted to calculate the minimum. So you go calculate, go to minimum, go to the left of the minimum. Then go to the right of the minimum. And those are basically at 0, 0. If we change that, that's 7.43 to the negative 11. And that is because we have a bad viewing window. So what I'll do here is press zoom 6 and then clear that out to make it a little bit better for when we find the 0. So I can go back to second calculate, and we want to calculate a 0. So to the left of this 0 here, you hit that. Then go to the right of that, hit that. And then it touches just right at 0. So it would be x equals 0. And then lastly here, we have the function 576 minus 16t squared. So I just put 576 minus 16x squared, delete out that extra 1. Going to graph that. And if you notice, this is way off because the maximum here is at 576. So I need to change my window. So from negative 10 to 10 is fine. And then the minimum, I should go from 0. And then the max above 576 would be 600. And let's have it just count by, let's say, 50s. So that works in there just fine. Now, if we're dropping it, this is my max height that we're dropping it from. So this whole part of the domain doesn't make sense in our math model. So we would just say, in this math model, the x number is bigger than 0. Now, my vertex is this maximum point right here. So I can calculate that and go second, calculate. We want the maximum. So going to the left of the maximum is here. Going to the right of the maximum is there. And it's at basically 0 for x and 576. And then to calculate the zeros, we have a 0 here and a 0 there. So you can just go second, calculate. We want a 0. We'll go to this 0. And I just arrow over, hit enter. Going to the right, hit enter. And the first 0 is x is -6. Or you could list that as an x-intercept of -6 for x and 0 for y. Same thing over here. This is symmetrical. So this is going to be x equals 6. And it is going to be at 6, 0.